So we are looking today at the study guide for the Chapter 1 Geometry exam, the multiple choice sections. So the first thing we are going to work on is the inverse, converse, and contrapositive. So we've got, right here, I just put it right at the top. If Zach receives a Lego City set for his birthday, then he will be happy. That's my original. My inverse, I have to put not in it. Inverse. If Zach does not receive a Lego City set, then he is not happy. I did put the word does in there to make it make English sense. Please make sure you do that as well. Shh. Okay. Number 2. We are talking about the converse. Anybody remember how to remember the converse? Inverse, you put not in it. What do you do with the converse? You flip it. So we're looking at, if Zach is happy, then he got the Lego City set. If Zach is happy, then he got the Lego City set. Please no side conversations. We're in the middle of doing this right now and recording. It's a really good microphone. Picks up all the way in the back. Okay, next we've got contrapositive, which is both. So, if he is not happy, then Zach didn't get the Lego City set. I started abbreviating because I didn't want to write the whole thing. Shh, your phone should be away. You should either be writing this down because you have not done it, or checking your answers if you have. Okay, any questions about number 1? We've got the inverse, converse, and contrapositive. Okay. I would say for number 2, what do we think? You should not be watching something on your phone right now, please. For number 2, what do we think? Is it biconditional or do I need a counterexample? Biconditional, the original statement and the converse both must be 100% true. So is it true that if Zach receives a Lego City set for his birthday, he'll be happy? I would say it's true. Converse, if Zach is happy, then he got a Lego City set. I would say that's not true because he could be happy for other reasons. My counterexample would be Zach got a bike and is still happy for his birthday. That's a counterexample. Or I don't know, maybe instead of a Lego City set, he got money and was able to buy it. You know, those are all counterexamples. Okay? So remember, when we talk about a biconditional statement, the original statement and the converse must both be true. And then you have the hypothesis, if and only if, the conclusion. Okay, it's that if and only if goes in the middle. Questions about inverse, converse, contrapositive, biconditional, or counterexamples? Any questions about any of those? What? So, exams are next week. Wednesday, which is the 22nd, is first and second. Thursday is third and fourth. So I don't go to tutoring because I have 2 small children, but I will have this recorded and posted. And I will also have, I've got the answer key all typed up, and I'll post that as well. Okay. So, and I will answer email all night long, but unfortunately, I got to pick them up from preschool and all that. Okay. Number 3, inductive reasoning. Who remembers what inductive means? Inductive means, coming up, inductive is drawing a conclusion based on patterns. For example, 2, 4, 6, what comes next? 8, because it's going up by 2s. That's the pattern. So inductive is drawing a conclusion based on patterns. Okay, so what do you think deductive reasoning is? It's based on rules. Deductive is based on facts or rules. For example, 7x equals 14. We would divide both by 7, so x would equal 2. It's based on facts or rules. Questions on any of those? Yep, deductive is based on facts, such as 7x equals 14. You divide both sides by 7, get x equals 2. Deductive is based on rules or facts. Now we're going to move on to some definitions. You ready? Okay. We've got a quadrilateral. Okay, quadrilateral is a closed four-sided polygon. Whoever phone is playing right now, I don't appreciate it. This is being recorded as well. Your phone should not be on. Closed four-sided polygon. Okay. Next, we've got that was number 5. Number 6 is a parallelogram. A parallelogram is a quadrilateral. Where opposite sides are parallel. Parallel is like they never intersect, they're right next to each other. Oh, parallel is just, it looks like stripes. It's 2 lines straight up and down. Okay. Number 7, trapezoid. A trapezoid has one set of parallel sides. And I did the abbreviation for parallel right there. Ladies, you will not be allowed to sit next to each other if you continue to talk while I'm talking. An isosceles trapezoid. How is an isosceles trapezoid different than a regular trapezoid? It has still one set of parallel sides, and it has the other sides, not the parallel ones, the other ones are equal. The other sides are congruent. So this is a trapezoid, just a regular one. Okay? This is an isosceles trapezoid, but better drawn. Not so messy. All right. Number 9. Number 9 is a rectangle, correct?
Kite.
Oh, kite. Kite. Adjacent sides are congruent. What does adjacent mean again? Adjacent. You're adjacent to Sydney. You're right next to it. Adjacent sides are congruent. That's that equal sign with the little squiggle on top. That means congruent.
This is for kite, right?
Hmm?
This is for kite, right?
This is for kite, yes. That's a kite that you fly in the sky. 10 is a rectangle. Rectangle is a parallelogram with 4 right angles. What about a rhombus? Who remembers what a rhombus is? It's still a parallelogram, but what is special about it? 4 equal sides, 4 congruent sides. A rhombus is a parallelogram with 4 congruent sides. Finally, we've got a square. A square is everything a rectangle is. It's a rectangle and a rhombus. Okay, I'm going to show you the flow chart so it kind of gives you an idea of how they're related and everything to each other. So we've got our flow chart. I'm giving you showing you up here. Not like I'm passing it out. You were supposed to make one. All right. Quadrilateral. So that's that four-sided polygon. We've got a trapezoid. Opposite sides are one set of opposite parallel sides. Isosceles trapezoid. Opposite sides are parallel. The other sides are equal. Base angles are equal. Diagonals are congruent in this case. Parallelogram. Opposite sides are equal. Opposite sides are parallel. Opposite angles are equal. Diagonals bisect. Rectangle, everything a parallelogram is, and it has four right angles. Diagonals are equal. A rhombus, everything a parallelogram is, except four equal sides. Diagonals are perpendicular. A square is everything a rectangle and rhombus is. Four right angles, four equal sides. And then a kite, adjacent sides are equal. It's got one set of opposite angles that are congruent. The diagonals are perpendicular. That's everything for the flowchart. Okay. Who remembers what the midpoint formula is? X1 plus X2 divided by 2. And Y1 plus Y2 divided by 2. That is midpoint. Okay, and the midpoint of the points that we were given for number 14 are 6.5 and 0.5. Who remembers what the distance formula is? Distance. Yep, y2 minus y1 squared plus x2 minus x1 squared, square rooted. And number 15 is square root of 34 or 5.83. Square root of 34 or 5.83. Okay. Number 16. For number 16, we're talking about a 45, 45, 90 degree triangle, correct? What is special about 45, 45, 90 triangles? The sides are both x, and so the hypotenuse is what? Nope. X square root 2. Okay? So for number 16, it says if both the legs are 8, so both of these x's are 8, what would this be? What would the hypotenuse be? 8 square root 2. Okay? 8 square root 2. All right. What does supplementary mean? Measures up to 180. What does complementary mean? Good. Okay. Let's go ahead and we're going to go over these for your unit circle. 18, cosine of negative 150 is negative square root 3 over 2. 19, sine of 90 is 1. 19, sine of 90 is 1. 20, tan of negative 30 is negative square root 3 over 3. Negative square root 3 over 3. 21 is negative square root 210, which equals negative 2 square root 3 over 3. Negative 2 square root 3 over 3. Number 22 is 1. Number 22 is 1. And number 23 is square root 3. Number 23 is square root 3. Questions about any of those? Any that you want me to repeat?
Yeah, can you repeat what SEC is?
SEC is 1 over x. So let's just go over that real quick. I think that's a good importance. Okay. Cosine is what, guys? X, good. Sine is y. Tangent is, who knows what tangent is? Please put your phones away and actually pay attention. Y over x. What is secant again? 1 over x. What is cosecant? And what is cotangent? X over y. Those things you do have to have memorized. They will not be given to you. I'll give you the unit circle, but I'm not going to tell you what sine, cosine, tangent, secant, cosecant, or cotangent are. Which one? Yeah. That's as big as it gets. I can't go any closer. Okay. So, Sydney, yes, I can. All right. Sydney asked if we could go over number 21. Okay. So for 21, I've got my unit circle, and I've got negative 210. So I go to 210, and the opposite of 210 is 150. So I know I'm looking at the stuff, So I know I'm looking at the stuff right here for 150. Secant is 1 over x. So I know that's 1 over square root 3 over 2. Okay? So this is when I got to write it down. I've got 1 over square root 3 over 2. Okay? So I've got, and it's negative. So I've got to flip that. So I've got 2 over negative square root 3. I multiply the square root 3 by the top and the bottom. I get 2 square root 3 over 3, and it is negative. Okay? Any other questions about the unit circle stuff? All right, let's go ahead then and look at number 24. Okay, we're looking at 24 and 20, excuse me, and 24 is all about finding the slopes and lengths of each side. The slopes and lengths of each side. Yeah, go step in. Okay, so I'm looking at, I want to find the slope and the length, and I'm looking at J to K, K to M, M to L, and J to L. All right. What is the slope of J to K? What'd you guys find? J to K. 2. What is the length of J to K? I wrote square root of 20, but you could have reduced that. What's the slope of K to M? Negative 1/2. So what is the length? I got square root 5. Is that close to what you guys got? M to L, I got 2 and square root 20. And then J to L, I got negative 1/2 and square root 5. So I got that the opposite, Savannah, why don't you move back to your side seat? I got, yep, that's why I want her to move. Opposite sides are equal. Opposite sides have the same, excuse me, there should be no talking now. Should have the same slope. Okay, opposite sides are equal. Opposite sides are the same slope. So I know right now this has to be a parallelogram. If you're looking at these slopes, you guys see how these are opposite reciprocals? That means it meets at 90 degrees. Okay, if it meets at 90 degrees, it is perpendicular. Okay, let's move on to 25. 25, we're looking for the slopes and the midpoints. Okay, slopes and midpoints of the diagonals. So for number 25, we have K to L. The slope is undefined because it's straight up and down. There shouldn't be any talking or whispering, guys. Knock it off. And the midpoint is 4, 5.5. Then we're looking at J to M. And the slope from J to M is 3/4. And the midpoint is 4, 5.5. So this means that the diagonals bisect, but they are not perpendicular. Okay, we're looking at number 26. Number 26. What shape is this? If opposite sides are congruent, opposite sides are parallel, adjacent sides are perpendicular, they have that opposite reciprocal, so they make 90 degrees. The diagonals are not perpendicular, but they do bisect. What shape do we think it is? Rectangle. And we're just going to list down everything I said to say what shape it is. It is a rectangle because opposite sides congruent, opposite sides parallel, adjacent sides, no. Adjacent sides are perpendicular. Okay? Diagonals are bisecting. When Brooklyn gets back. Okay. Questions about any of those? Are you guys comfortable finding the length and the slopes? I mean, personally, I would just do the Pythagorean theorem on here. Okay, how many did you go up? How many did you go over? And then do the square root of them. So in this case, this is 1, 2, 3, 4. This is 1, 2. So I'd go 4 squared plus 2 squared square rooted. That equals the length. But you can use the distance formula as well. The distance formula is that, you know, y2 minus y1 squared plus x2 minus x1 squared. Okay. All right, let's go on to number 27. So we are looking at 27, and I'll just go through it pretty quickly. 27, the slope from Q to R is 2/3. The distance is square root 13. The slope for R to S is negative 2/3. The distance is square root 13. The slope from S to P is 2/3. The distance is square root 13. The slope from P to Q is negative 2/3. The distance is square root 13. So we have all 4 sides are the same, which means it could be which 2 shapes? Square or a... Nope, rectangles don't have 4 equal sides. What has 4 equal sides? Nope. Rhombus. There's no such thing as a diamond. Okay, so it's either a rhombus or a square. Now, opposite sides are parallel, which still could be either, but the adjacent sides are not perpendicular, so I'm thinking this is a rhombus. But to double check, I'm going to find the lengths and midpoints of the diagonals. The length of P to R is undefined, the slope. The slope to Q to S is 0, which means they're perpendicular. The midpoints are both 6 and 5. So this is a rhombus because it has 4 congruent sides, no perpendicular sides. It also has 4 parallel sides, no perpendicular sides, and the diagonals are perpendicular and bisecting. Questions about any of those? Okay, I think we'll stop there just because I feel like your attention is gone. And we'll finish this up on Tuesday. So we're going to do 30 through 48 on Tuesday, and I will record that. Okay. This is a great chance because this was due at the beginning of the hour today. You should practice 1 through 30 and check your answers with this.
Can I sit over there?
Okay.